So hi guys and welcome back. Today I would like to talk to you about closures and lambda expressions in function. So we're just going to briefly talk about some like basic functions, of course, and then function threads like FnMut and FnOnce. So I would like to clarify those topics for you in case someone is still finding it difficult working with those in Rust. So we're gonna keep it as fast, as quick as possible. And I've just gone ahead to start a new project. As you can see here, there's really nothing in here, just a simple hello world. So again, this is like a quick example of a simple function. So, but let's just quickly do something. So I could come down here. We're not gonna really pay attention to our visibility attributes for now, like public and all that. Everything we're gonna do, I will actually leave in this main file. And so let's assume we have a simple function called greet that takes a name, which is I'm going to be a string, for example, and maybe it actually returns a string. And this is really simple. We can do, there are so many ways we can return this. I can do a simple format and maybe say now hello, and I actually provide this in here. And maybe add, just to make it interesting, and I provide the name as simple as this. So this is, of course, something you are probably already familiar with. There's nothing so special here. The only thing is it's a very simple straightforward function that takes an argument and of course also returns an argument. So that's a pretty straightforward function. We can really come in here and create and basically use the function. I'm just gonna maybe call this Tony, something like this. And of course I have to close this up because of course the main function doesn't need to return anything anyways. And that's pretty straightforward. This is going to say again, hello Tony, whatever. And yes, of course, this is, now I can just maybe take this, cut it, and then replace it, put it in here basically. So I'm just going to put it like this. I maybe remove this one and get rid of this. While this line here, we don't need it, of course, we don't need it anymore. So now let's see. So it should say hello Tony, pretty straightforward. So it returns a simple argument. And of course, I'm trying to, of course, lay the ground basically so we can really, when we get into this different function trace, of course, it will be a lot easier to grasp. So we have a simple function here. I'm just going to call this one divide. So it's going to take two arguments that are going to be, I'm just going to call them x and y. So those are going to be f64. So they're going to be floats. And y, of course, is going to be a float. And what I might want to do is that I would like this function to again return two things. So I have to now return those as a tuple. So I can provide there again f64. So this will be the return types, pretty straightforward. And maybe now I can define a function, an argument called quotient. So quotient would be very simple, x divided by y or whatever. Something like this, come on. And then again, I have another one as a remainder. Remainder would be, I use this percent sign x percent y. And now I simply return both like this. So I say quotient and remainder, pretty straightforward. And then of course we can again come inside here and then use this like this. So I'm just gonna call this QR would be equal to divide. So I'm just gonna pass 23.0 or 9 or whatever. It doesn't really matter. And that's it. And really that's it. So we have these two values and we can of course consume this whichever way we want. So those are like pretty straightforward. So but the only thing you might have noticed, for example, at least for this divide, is that we provide two arguments, and this function more or less actually takes ownership of these arguments, and we get back of course two floats. So what it means is that we can also have a function that is quite simple and straightforward like this. I'm going to call this take ownership to buttress the point I'm trying to make here. So it's going to take, say, a string, and maybe it doesn't really do much with it. Probably just going to print this to the console. So I'm going to say this is the argument, whatever, and I pass the argument itself. And of course, it doesn't really take anything. So, but the point is that it's going to take, of course, ownership of this argument. But again, we can also have a similar function. I'm just going to maybe call this one borrow value, some like this. And now, of course, now I have to pass this as a reference to string, for example. And then in this case, this function gets to not take ownership, but rather actually borrow this function, actually borrow this argument rather. And what we can quickly do is to maybe come up here, I create a string, and I'm just gonna call this s as a string from, and I'm just call this arg, whatever, doesn't really matter. So this is gonna be our string. And now we can actually call this function that takes ownership and pass this string to it, and everything, of course, should still be fine. But if we wanted to call this down here, of course, we're gonna get a couple of errors. So one would be the past argument, of course, is wrong. And then, of course, if we bring this up here, so I'm just gonna cut this and bring it up here, and maybe now change the type to, of course, a borrow. Now everything should be fine one more time. Yeah, because of course our function borrow value takes doesn't really take ownership of the argument. It simply takes simply borrows it. But this take ownership function, of course, actually takes ownership of the arguments, and that means if we actually copy this, come here and try to run this function a second time, we would actually have run a problem into this because right now at this point at line 6 the string s no longer exists anymore, because of course this took ownership of it, and when this function was called after line 12 it was actually dropped and went out of scope. So that's really it, pretty straightforward. Now let's actually talk about some interesting things. We said we would like to talk about closures, and I can create a simple call it a simple closure like this. I'm gonna probably call this add one. So to define this, of course, closures are more or less like functions, but they are like lambda expressions. That they're actually lambda expressions, like you also would have in most other programming languages. They are also unnamed, so they are more or less defined without a name. And to define this, of course, is pretty straightforward. I'm gonna write something like this. Again, it's more or less defined the way you would a regular function, because within this closure you get to now, of course, provide the arguments you would like this lambda expression to have. And in this case, I'm just going to give it a type. I'll probably just make this I32, and now I actually have my first lambda expression defined. But now if you look over here, you actually see the type of the function that was, oh, sorry, the argument that was created, or in this case, a lambda expression. It's actually not really a function, so to say, but it actually, you can actually think of it as an argument in this sense that implements this function. Of course, we take an I32 as an argument and also returns an I32. So that brings us to the kind of closures, more or less, or function traits that I would like to easily talk about today. Or actually, I can actually remove this, it's not necessary. So now I have this FnMut, and FnOnce. So because whatever we have here is completely dependent on also what's passed. If I make this I64, for example, now this also changes. So it's of course dependent on the arguments being passed to it. It can also, of course, we can also maybe not even pass any argument. That's also totally fine. But again, we'll still talk about those going forward. Okay, so but let's proceed. For this simple closure we just defined, we can maybe also just I don't know, maybe simply just print the result. And so I'm just going to do something like this. Well, actually, I don't need to provide any further thing in here, so I'm just going to go ahead and simply just call this function and then pass an argument. I'm just going to maybe say 122, and that should be fine. So now I can easily actually run this function and let's see what we get. So if we run this, of course, we get this back because really it's really not doing much. It simply takes what we provide to it and then add one to it. That's a really simple, straightforward Lambda expression or a closure more or less in Rust. So at this point, I would like to, of course, try to talk to you a little bit about this threats because these are actually in essence threats. So we've seen like the very simple the first one. So just to clarify things, of course, we have here FnMut. So it's so closures that basically implements this FnMut threat. They can borrow values from their environment mutably, and they are also simply, of course, means they can also mutate those variables. The difference, of course, let's say with FnOnce would be that um, closures more or less that implement these threats, they can really consume. So you call them, for example, with the move keyword. So they can consume the values from the environments that you actually pass into them. And then what you also do in the process is that you end up transferring ownership to those closures. And of course, because of that, they can actually only be invoked once. So at this point, you might again now be wondering what then would be the difference, of course, between this and this. The main difference, of course, is that with FN, we basically have the option of actually borrowing a value, but the point is that the value borrowed is actually borrowed immutably, which means it cannot modify that captured variable. So what to actually verify that, what we can simply do is I'm gonna come up here and create a variable x, and maybe I'm to call this 122, just like we did before, so nothing is changed here. And now what I can do is here I'm just going to pass that argument, and maybe down here I try to again print the value of x. So here I can say the value of x, something like this, and then we can actually run this one more time to actually see what happens. And here, of course, you see the value, of course, remains unchanged, because that's also how this is designed. So this, of course, can be used when we want to borrow a value immutably, where we do not want to modify the captured value. And then, of course, FnMut would be when we would want to borrow a value mutably, so that we have the option of modifying that captured value. That's really the major difference. So what we can quickly do is to see how we can implement, of course, the FnMut threat. I'm going to come down here to define a new function, and maybe I'll just call it apply FnMut. So we're going to need to specify, of course, the kind of arguments I would like this function to have. So I'm just going to call this f, which is going to, of course, define what I want to pass over here, and I would have to define what f means later, but let's just proceed. So it's going to take an argument called f, which should be mutable, and that f should be of type f. Now what I need to do is now, of course, maybe come down here and now define what else actually is. So now I can say f, of course, would be want it to be of FnMut, so it takes no argument and also returns no argument. So you have the option, of course, you have the freedom to do whatever it is you would want to do here. And though for now this is really not going to be doing much, we simply just call the function, simply just invoke the function. That's really all it will be doing for us. So basically it takes a function that implements the FnMut thread and simply invokes that function. That's really it. Again, the difference between this and Fn is that this would mutate the value being passed to it, more or less. So to, of course, see what's how that could look like, see, I'm probably just going to come here and say FnMut just so we know where we are. And I'll try to maybe create a closure up here. So I'm just gonna maybe add, let's say add two, for example, and then it's gonna be a closure. And what I will try to do would be to maybe modify the value we created up here. So I'm just gonna probably say x plus equal to 2, something like this. Yeah, but the only issue now, of course, is that x is not mutable. So we have to come here and make x mutable. And now this should be fine. So what we can now quickly do is to come down here and call apply FnMut, and now I simply add 2. because this is going to modify the value for us of x. And now what I can quickly do is maybe come down here and then print this out so we see what we currently have. So I'm probably just going to say, so I can simply say something like the new value of x after FnMut, something like this, and then I simply just provide x like this. And then of course we are not returning anything here. So again, if you look at the signature of the function now, it's no longer looking like the one we had over here. It's completely different because we are actually mutating the x. So now if I just call this function again, as you can see, pretty straightforward, we will see that it simply just adds to like we expected it to behave. So for FnOnce is also pretty straightforward. I'm just going to copy this, what we have here, come down here and paste this. And of course, I'll rename this to FnOnce. And the only difference actually here is that, again, this will not be passed as immutable because, again, remember we said this takes ownership of the variable that is being passed to the closure. So basically, it will take complete ownership and it can be borrowed mutably. So we change, of course, the signature of the function we're expecting here to be FnOnce. And then maybe I can actually let this return an argument. So I'm going to assume that this will take a closure that basically returns a string back to the user more or less. So now, of course, yes, I have to close this off to make the difference. So that's really what the signature looks like. Again, it can get complex, more complex like this, again, depending on the passed argument, the returned arguments, and whatever the case might be. But I think this should, of course, explain what we need to understand here. So I say FnOnce, and then down here, maybe I just create a new string and I call this new, I don't know, new string, something like this. And I say string dot from. I'm just going to leave that value in there. Sorry. And now what I can do is to create my closure. I'm probably just going to call it closure. And again, I have now I'm using the move keyword, as you can see. So it's a closure that will not take any argument, but it's simply going to return new string. Okay, and now of course, because of that, we now see the signature now changes to FnOnce. So you can actually play around with this and see what you get. But let's proceed. So now what I can simply do is now come down here and call our FnOnce function. So I'm going to pass a closure, closure like this, and then this should give us back a string. Sorry, the function, of course, is not returning a string. It is the closure being passed to it that actually returns a string. So, but we get to handle all of that in here, doesn't really. So this one, sorry, down here is actually the one that's returns a string. So if, for example, we do something like this, we can actually set a string and we'll do whatever the hell we want to do with it. But yeah, this apply FnOnce function doesn't really return that, so that's had to specify. Of course, if we wanted to return that, maybe we can actually put that in here, something like this, and then here I can actually do something like this, and now we can again see this. But again, we are passing the same argument, so it doesn't really make so much of a difference. So just to clarify again, of course, between all of these three, so FnMut, Fn and FnMut takes so Fn can borrow values from the like within your environment immutably, which means they can't modify those values. FnMut will modify those values, but FnOnce we take full ownership of those values. That's really the major difference between the three. So that's actually all I wanted to show you guys in this short tutorial. And yeah, that's it, guys. We're calling it a wrap. Of course, if you're new, go ahead and subscribe and turn on the notification bell, and we'll definitely notify you when we have a new recording and new information to share with you. Anyways, guys, I'll see you next time. Have a lovely evening.